Let's continue our lesson with the second part, the part 2. In this part, I will give you an example how to solve the problem. So this is the example. So we know that temperature distribution across a wall, the thickness of the wall is 1 meter. At certain instant of time is given as the function of a plus bx plus cx squared. Remember, this is the function of the distribution temperature, where the T is in the degrees Celsius and x is in meters, while this is the A value is equal to 900 degrees C, the B value is minus 300 degrees C per meter, and the C value is minus 50 degrees C per square meter. Then a uniform heat generation, or Q dot, equal to 1000 watt per cubic meter is present in the wall of area 10 square meter, having the properties of the density is 1000 x 600 kilogram per square meter, per cubic meter. The heat conductivity is 40 watt per meter Kelvin, and the heat capacity is 4 kilojoule per kilogram Kelvin. So you need to determine 3 things. First, you need to determine the rate of heat transfer entering the wall, so when x equal to 0 and leaving the wall, when x equal to 1 meter. In this case, you need to determine the Q in and Q out. Second, determine the rate of change of energy storage in the wall. It means we need to calculate the E dot ST. And the third, we need to determine the time rate of temperature change. The time rate of the temperature change at x equal to 0. This is the coordinate x when the x equals 0.05 and 0.5 meter. So it means we need to calculate the dt, capital T, round dt over round d time. Okay, let's change the marker with the black one. So this is how we answer. So we need to make the schema of this figure. So this is a one-dimensional. So there will be a Q input here and Q out. Okay, this is the first question, and this is all the parameter is written here. Okay, and this is the function of the temperature distribution. So there will be a heat that generation and heat that stored, and the length of the wall, thickness, is 1 meter. So I will write again the value of A. Okay, remember the value of A is equal to 300. Sorry, the value of A is not 300. The value of A is, wait a moment, let's go back to the previous. The A is 900 and B is minus 300. Okay, so the value of A and okay, let's write here A equal to 900 degree C, the B equal to minus 300 degree C over meter, and C is minus 50 degree C per square meter. Okay, this is the all the variable we need to calculate. So for the question number 1, we need to determine the Q input and the Q out. So remember the Fourier's law. Fourier's law of the heat flux, the Q double prime X in one dimensional is equal to minus K on the temperature over on the X. So we can change this equation, okay, into the Q X, or the heat transfer rate, by multiply it with the surface area. Okay, so the Qx, when the position equal to 0, it means this is the Q in. So the Q in equal to Qx, or heat rate, when its position equal to 0. Okay, so this in this part is equal to this equation minus K multiplied by A on dt over on dx. And we put the boundary when the x equal to 0. So this equation is simply changed to Ka. Remember the T, this is the T distribution is A plus Bx plus Cx square. Okay, for the x when the x equal to 0. So this is only one-time derivative. So the A will be 0, the Bx will be B, and we have the 2Cx. So this equation become minus K A B plus 2Cx. Okay, when x equal to 0. So this is the first equation we get. So now we can put all the value. So the Q in is equal, so the x equals 0 means the 2Cx term will be finished, so we only will have the minus K A B. So it means the K value is 40 watt per meter Kelvin, okay, multiple by the A is 10 meter square, and then multiple by the B, small b, so multiple by minus, so since this is minus, so it becomes positive, okay, so this one become positive, sorry, erase, so all is positive, so we will have finally, okay, multiple by 300 degree C. Okay, you don't have to convert from the Kelvin to the Celsius, okay, because sometimes this one can be changed into meter Celsius, it's the same. Okay, so we don't have to calculate, sorry, we don't have, sorry, this is Celsius per meter, okay, so if you calculate what we'll get, so this is will be equal to 40 and become 400 times 300 is 12,000. This is 12, not 12,000, but sorry, 120,000 watt, or equal to 120 kilowatt. Okay, you can pause the video, so I will erase. If you finish, I will erase. So now for the Q out, so the Q out is similar with the Q in, however for the Q out you need to put when the x equal to L or L equal to 1 meter. Okay, let's do it. So this is still the same for yellow. So for the Q out here, Q out is equal to Qx when x equal to L. So the equation is become minus Ka on dt over dx when x equal to L. So this equation is the same. So we will have is minus Ka multiplied by b plus 2cx, but x equal to L. So we put the x equal to L, so we have the minus b plus 2cl multiplied by Ka. Since the L equal to 1 meter, so we can have the substitute all the value become, so this one is minus B is minus 300 degrees C per meter plus 2, the C is minus 50 degrees C per square meter multiple by 1 meter and multiple by K. K is 40 watt per meter Kelvin multiple by A. A is 10 meter square meter. Okay, see in this part is 2 multiplied by 50 is 1 minus 100. So this is minus 300 become minus 400 and this one become positive. So we get positive 400 multiplied by 40. So we get 160,000 watt or equal to 160 kilowatt. This is for the Q out. So if you need more time, you can pause the video. So I will erase again. And to make remember, we need to write the function of t. This is the t is equal a plus bx plus cx squared. Okay, the second question. Second question, we need to find the rate. So the rate of energy storage. Storage E dot st. Remember the equation to find the energy storage is come from the energy rate of energy input plus the rate of the energy generated minus the rate of energy out, so it will be the energy that's stored in the system, and the energy generation or A dot G can be written as the Q dot multiplied by the volume or A L. Finally, we can have E dot SD equal to energy in plus the energy generated minus the energy out equal to the energy in equal to the Q in. So we have the Q in plus the Q dot AL minus the Q out. So we write here the energy that's stored will be equal to the value of the Q in is 120 kilowatt. The out is 160 kilowatt. So we have 120 kilowatt plus the Q dot is 1000 watt per cubic meter multiplied by A is 10 square meter multiplied by 1 meter, and finally multiple by the minus the Q out. Okay, minus 160 kilowatt. Okay, if you calculate it correctly, this term we will have 10 kilowatt. Okay, so this one, the answer will be minus 30 kilowatt. So what is the meaning of minus? So it means it's a decrease over the time, because between the input and output is higher the output. Okay, you can pause again this video to take a note. So I will erase all. Remember we have the t here. T is equal a plus bx plus cx square, and the a is 900 degree C, b is minus 300 degree C per meter, and c is minus 50 degree C per square meter. For the question number 3, we need to find the time rate of change of the temperature. So the time rate of the change of temperature, or simply we can say round the temperature over round the T. So remember again this equation, the heat equation, in one dimensional. Okay, so we need to find, right, this one means the on the temperature over the T. So we rearrange this equation into this one, equal to K over rho C T over plus Q Q dot over rho C. Okay, this term means this temperature distribution is derived twice, or second derivative equation. So we can write the change of the temperature distribution. Okay, this one, the dou square T over dou x square equal to A plus bx plus cx square, okay, dx. So the first derivative, we will have the x. So this one become 0, b become only b, and this is 2cx. So we have b plus 2cx. And we derive one more time, so we will have only 2c, and put the value of c, we will have the 2 multiplied by minus 50 degrees C per square meter. So we will have minus 100 degrees C per square meter. Okay, this is not the end of the question, still not a finish. So we will still need to find the round t over round dt. Okay, we still need to find this term. So please pause the video, and I will erase all again, and I will put the blue color. So for the temperature over the time, so we will have the equation is written as this one, K over rho C d square T over dx square plus Q dot over rho C. Okay, we already know that the round square T over dx square equal to minus 100 degrees C per square meter. So using that information, we can calculate again. So put the K is equal to 40. Okay, K is equal to 40 watt per meter Kelvin over the rho C. So this is 1600 kilogram per cubic meter multiplied by the C is 4 kilojoule per kilogram Kelvin. Okay, this is the first term, and plus the Q dot is 1000 watt per okay, is multiple by the value of this one. So multiple by minus 1000 degree C per square meter. So plus this term is 1000 watt per cubic meter over this one. So if you calculate it correctly, so we will have the value of this one, of the first term, is equal to minus 6.25 multiplied by 10 to the power of minus 4 degree C per second, and the second term will be positive 1.56 multiplied by 10 to the power of 4 degree C per second. And finally, the change of the temperature rate is minus 4.69 multiplied by 10 to the power of 4 degree C per second. So this is the answer, and this is the end of the second part. So next we will go to the third part, so you can pause this video to take a note.